So we have started chapter 9 in the last class, right? What is chapter 9 about? Centroid, centromass, probability, right? Centroid. So do you still remember what is the equation that we have covered? And this is if we are calculating centroid, right? And in center of mass, the M, center of gravity, dW, right? Center of volume, centroid of volume, dV. Now, so in the 9.1 we have covered how to deal with integration. Normally, if the area or shape is not is a curve, etc., then normally we do integration. However, in how many of you have watched the lecture? So in terms of application in many construction components, for example, it is combination of basic shape. For example, something like this, etc. Have you seen beam like this? Right. And especially there's a lot of things like this, but it's basically a combination of rectangular, and rectangular. Right? So when we have basic shape, we might not have to actually integrate because basic shape we know already the central of the shape. So in 9.2 we will deal with composite area, meaning that you divide. Meaning if you have, okay, just like now, you divide into this and this. So we have 1, 2, 3. This whole shape is combination of this three basic shape, for example. Right? So that is what we mean by composite, is combination. So in terms of that, we'll just have the equation will be something like that. The meaning is the same. This is integration is actually you add up all the elements, right? The splits area and the graph also. And then this one is just okay. Why is it D? Because it's a differential element, right? Here is just A because the area of this shape, area of this shape. Right. So in terms of the meaning of this equation, this is summation of all areas, so meaning area of this plus area of this plus area of this becomes the total area. Right. So that is summation of all areas. Summation of x wave area, meaning that for this one x wave times A, for this one x wave times A, for this one x wave times A, you add all of, you have the summation. So that's the meaning of this equation. And of course, if you have to find y bar, etc., then something like that. Right? Now, if you have z, then z. Again, this is if you are dealing with two-dimensional area. Is if you are dealing with 3D volume, then V here. If center of mass, M, if center of gravity, W. Same concept as that one. Alright, so that's basically what you need to do for, you need to know for calculation wise. Any question? Because we'll go straight into the previous exams to see the type of question that can be asked for this type of. This one. Okay, we'll try to find the easiest one first. Now in chapter 9 and 10, basically you can have the same diagram, but the question is different because both can have integration question, both can have. Alright, let's start with this one. Okay, so the question is straightforward. Determine the centroid of the shaded area. Okay, in terms of the steps, this is the equation, but the step, okay. One, divide into segment. Two. Normally we expect you to answer in the form of table for this kind of question because okay, what is needed? Okay, this question asks for centroid, right? What will be the final answer in terms of what? X bar, Y bar. Meaning that what you have to plug into the equation is summation of A, summation of X with A, and summation of Y with A. That is the three component you need, right? So basically you will make a table where you have like segment, and then the area, and then X with, Y with, and then this is just multiplication. Like where this 3 is you have to determine directly from the question, and this one is just you multiply X with and B. So this is multiply Y with and B. And then finally at the end here you have summation of area. You can plug in this. Here you have summation of X with A, and also you have summation of Y with A. And then you can just take the value to plug into this one and this one. So normally that's how this kind of question is solved, right? Alright, so let's take a look at this question. How will you divide the area? Now, to solve this kind of question, because we have covered before, right? The concept of where is the center. For example, the centroid of a rectangular is at the middle there. The centroid of a triangle, right? So this is 1/3 of the length, for example. This one is 1/3 of the height, for example, right? This is if you have a right angle triangle. Circle? Vertically center, right? What else do we have? Semicircle? Length. What is the height? Okay. Now there are some shapes where anyone who have a textbook? Okay. Now in the exam, if you are given shape like this, then you are expected to know for each shape where is the centroid of this, right? But if you have semicircle, etc., normally they will have to give you the table at the back of your book, right? So there's the table like this, where you have quarter circle, semicircle, semi-parabolic, parabolic, etc. Right? So if this kind of shape is given, you need to know how to use the table, right? Because here you have information for chapter 9 and also chapter 10. Alright. And make sure you understand also that if you have the table, now for those who have your book, you can refer to it. For those who do not have your book, you can just Google the name of the table and you should be able to find the table. Okay? You can see that there's on top here there's something similar in shape. But if your photocopy is not good, then you might not see the difference. But if it's good, then one is shaded in area, meaning it's the area itself. One is actually just the line, meaning there's a line of semicircle and there's a shape of semicircle. The area, right? For our syllabus, actually in terms of centroid, we have the line, the area, and also the volume. But we totally skip the line because it's a bit more challenging for most students, so we just skip that one for our statistics syllabus. Alright, so make sure you know how to use that table going into the exam, because for this one you will not have to see it, you will not be given the table, but we'll see exam after this. Sometimes they will give you the table when you have to see it. Alright. Okay, straightforward, right? So, okay. Another thing in your exam, how it is different from your midterm is that in your midterm you are answering right on your question paper. But in exam, the question paper and the answer booklet is different, right? So if you need to actually redraw something, for example here, I label this as 1, 2, and 3, right? Hence you have 1, 2, 3 here. But if this one is nowhere in your answer booklet, then it is not clear what is this 1, 2, 3. Right? You have to draw it on your answer booklet. Do not draw it on the question paper because the question paper will not be together with the answer booklet. Right? Alright, so let's try this one. This should be straightforward. Okay, for area 1, which is this triangle, what is the area? So it's straight away half times 300. Okay, if you use okay, no problem. 300, 200, right? This is in millimeter. What about area 2? Area of the rectangular number 2? 100. What about the circle? Now, this one is a hole, right? So you have a minus area. So, okay, normally this question is very easy. It's just that sometimes mistakes happen. One is if you forget this negative where you have minus area, right? What is if you have, for example, if you have axis here, right? Let's see. Then this side have a negative coordinate. Right, so that's the two things that can happen in terms of mistake of you forget the negative. Right. Alright, what is x way for the triangle?
It's 100.
100 here? 200 here? Okay, a reminder, this thing here, x way, y way, is the coordinate. Meaning it's not a distance, it's a coordinate. Meaning from this axis, this point here, what is the coordinate? Right, so of course you know this is 100, this is 200, right? But the coordinate of x is 200. What about coordinates of y with? Divided by 3 is 1 over 3 times the height of 200, right? Any question here? Do you understand? Okay, for this rectangular number 2, what is x width? 450. Everyone agree?
Yes.
You know how to get 450?
Yes.
It should be here at the middle here, right?
Yes.
So 300 plus 150. Y wave? 100. From the circle, x wave? 450. 100, right? Any question? So I think mistake tend to happen if you forget to add to get the coordinate. Right? You just have here and then you forget to add this coordinate, for example. And the rest of this is just using your calculator, right? Meaning S with A is 200 times this one, etc. And then summation of A is just add everything. Summation of X with A is add everything, etc. And then you just plug into the equation. So the question for this one is very straightforward and you cannot trick because the answer is just exactly like this. Just make a table and just plug it, right? So the only thing that can make it, how to say, it's not a trick, but to make the student do mistake is one, if suddenly the axis is somewhere. For example, if you have, I don't know, a block like this, right? So you have a coordinate of negative, etc. For example, whole, you might forget negative. But I think there's one question that quite long ago where it's quite confusing in terms of. Okay, I think there's a question after this where you have to do some mathematics to get the right, the way they give the dimension. Anyway, any question? Pretty easy, right? Now, normally if this kind of question come in the final exam, if anyone who do not get full mark, I will cry. You should get full mark for this one. Now, just to show what can happen, right? If you make a mistake here, for example, right? If you make one mistake here, then this one will be a mistake, this one will be a mistake, and this one will be a mistake, right? If you make a mistake here, then this and this mistake, this and this mistake, and the whole thing is mistake, right? So that's the chain reaction that can happen. So make sure you check and double check, right? Alright? Otherwise, the concept is just straightforward. Okay, so let's take a look at. Okay, this is what I mentioned where the dimension can be quite confusing for some. Right? Okay, we'll go to the question first. The gravity wall shown in figure 5 is made of concrete. Determine the location x bar y bar of the center of gravity for the wall. If the area is divided into segments for calculation, clearly label the segment. Alright? So this is the thing. Right? Now, the question asks for what? Okay, what of what? Is it centroid or center of mass or center of gravity? The question actually specifies center of gravity, right? Now, so what equation should you use? Is it W here? Or can you use A? Okay, is it the same location or different? The centroid dengan center of gravity? Yes, because it is homogeneous. Everything is concrete, right? So that's why from that understanding you can just calculate centroid. That the answer will be the same as center of gravity. And even one thing is that I think they don't even give any density. Alright, please try and see what you can do. Just make a table. However, this one, what I want to see is how you actually divide the area. ada shape ni tak boleh. Kita ada shape, kita bagi semua shape jadi macam contohnya rectangle atau triangle. So how many segments do you have? 2, 4, 5, 6. Now, there's multiple way you can divide, right? But most of you are doing macam tak bagi. Okay. Do you know this all the information is it? You can try, but the thing about this one, right? You know the x and the minimum is higher, but in terms of the x wave, can you get? Now the easiest and most straightforward is normally we just divide into shape that straight away we know the central result long calculation, right? So normally in this case you have triangles and rectangle, right? Of course there are other options also when you can see the table, right? But some of it require more calculation in that sense. Okay, there are some students that I noticed in the final exam at that time they use something like this minus this and this and this. Okay, can you understand this? Meaning they take the whole 15 and then minus this one and this one and this one. Right? It gives you the same answer. But I think many will just use just divide something like this. Right? Something like this. Right? Most of you divide something like that. Okay. So anyway, as long as it is correct, then it is correct. Ada yang I don't know, they have this rectangular and then minus this triangular. Itu all. But that is where you have to actually indicate what is going on so that when we go to the segment, the examiner will understand what's going on. Right. Alright, if we take something like this and we label it 1, 2, 3, 4, right? So 1, 2, 3, 4. What is the area for 1? How do you get that value? This value is 0.6 times 4.1. Area for triangle number 2? Half times. What's the length? What's this length? 2.1. Okay, bagaimana? Masalah. And then 3. Is this correct? How do you get 2.1? Actually, you have this one minus this one, eh? So 3.5 minus 1.4, which is 2.1. So this is 2.1. Rectangular number 3. What's the length? 1.4 minus 0.6, is it? So 0.8. 3. This is 0.8, is it? Okay. Verify. The triangle here is half times 0.6 times 3. This is 0.6. This is 3, right? This is 0.6. for rectangular number 1, x wave is what do you get? What's the total? 4.1 is it? 4.1 what is it? 2.05. What is the y wave? 0.3. For this triangle, what's the x wave? Huh? 2. Ada yang tak tahu yang bakal ke tak? 2. How do you get 2? Okey ke tak ni? Mari. Ke tengah tak? What about y wave? Huh? 1. 0.6. You have to add this 0.6 here, right? Okay, for this block number 3 here. .7 plus 0.4 3.1 y wave 2.1 number 4 x wave 2.7 3.7 betul? Tadi kan? 3.7 y wave and then the rest is just you use your calculator to calculate and then got the summation and then bagi. Right? Anyone have any question with regard with any of this value? Ada tak jelas kat mana dengan? Okay. This is an example of question where I think it's better if you redraw it so that you can see the detailed distance. Otherwise, here it's not clear where what is this, right? Clear? Of course, you can discuss with your friend, etc. If you do not understand any of this. Cari dapat. Salah. For segment 2. Next week. Oh, ya soalan ke nak cakap? So segment 2 the central is here. This is what 21 0.7 1.4 Again, if you need, you just draw everything lah. Right? So that it's clear that x coordinate, y coordinate, etc. And if you have a tendency to make a mistake in terms of the coordinate, you just also draw the axis also, right? Lagi clear where is the axis. Okay kan? So again, question like this is very straightforward, except if you make a mistake. Any question before we go into? I think there's 3D question in the other question. And by the way, there are also questions like this. Propose a way to lower the center of gravity of the wall that we just solved. There are two constraints. One is the height of the wall need to be maintained at 3.6, so meaning that its total height should be 3.6 still, and the length of the base should enter 4.1. So this whole thing should be maintained as 4.1 at the base. Okay, so what do you propose and why? How that will be making the center of gravity low? This is just understanding question, 3 marks, right? You just subjective answer. Okay? How? Change. How? If you just say change, it can be higher or lower, right? So change. But the idea is that, meaning, I think from understanding you should understand that what can affect the center of gravity location is one is the shape itself, one is the material. Meaning if you have different density material. So any answer that is logically correct. But if you want to change the shape, you have to actually draw something. How? What shape? Some say, oh, I add also here. Will that make it lower, for example, or make it bigger? Or I don't know. So whatever. Some actually says I omit this one so that the height is still the same, but the upper side have lower area. So any logical answer is correct. This one doesn't have actually one answer scheme. It's just kalau kata omit the density of this one and this one is different in what way. Faham ke? Alright, so I'll go for this. Alright, this one first. Okay, the question is locate the center of mass of the block shown. And then here you have 3 different material. And the question already give the number 1, 2, 3. If you have question that already number the segment, do not change the number, right? I don't like this. I want this 1, 2, 3 because then the examiner will be very confused. Right? So, and the density is given. Okay, because we are scoring down, so I'll just write it here. So density for material 1 is 7.8 megagram per meter cube. Material 2, 5.7 megagram per meter cube. Material number 3, 2.7 megagram per meter cube. Right? Because we want to scroll down. Okay. So this is basically the density. So we need to locate center of mass. So what equation do you use? This one will be M, right? Can you use A? Why not? Yeah, the density is not the same, right? It's not homogeneous. Alright, you can try. So meaning that the column here, okay, the implication here is that you have X, Y, Z. So you have more column. And then you do not want A, but you want M. Right, so you can make your table and then so it will be the table will be looking like that, right? Is there any problem to get the mass? Okay, the density is there, right? Nampak? betul SMS? Basically, the unit already gives over here, right? So this is what is this? This big M is what? Megagram per meter cube, right? So as long as you get the meter cube of volume, you multiply, you get megagram. Now, in this case, because the density is in meter cube, then when you calculate volume, it should be in meter cube, huh? To multiply, right? So sometimes it is safe that you actually write the unit so that you do not. Because if you do not write the unit, you just multiply 7.8 times 20 whatever, sometimes the unit is wrong. Okay, another thing. Even if you calculate volume in millimeter, right? In millimeter, and then you want to millimeter cube, you want to change to meter cube, you have to multiply by what? Okay, if millimeter going for meter is 10 times 93, right? Millimeter cube to meter cube times what? It's basically 3 times this one, right? It's power of 3, right? Because it's right? So in the final exam last time, many students just times this one. Meaning like for example 1000 millimeter cube suddenly become 1 meter cube, which is totally wrong. So do not make mistake like this. Or otherwise from the beginning you just use in meter. Alright, so in that case if we just go 7.8 megagram per meter cube. So the volume of if we to use in meter then 0.03, 0.06, 0.02. This is meter cube, right? If you use 30, 60 and 20, then it will be millimeter cube. Number 2, 5.7 megagram per meter. Mega is 10 power 6. Okay, what this block? 0.04, 0.06, 0.02. This one? 0.7 megagram per meter cube, and then 0.02, 0.06, 0.06. Any question on this part? Alright, let's get with physics, right? Alright, so let's check whether we can get all this correct. What is x wave for block number 1? 10. In meter, in millimeter. Oh, okay, because when you want to multiply, etc., then make sure the unit tally or something, because otherwise whatever we have here will be in different units. If you use meter, then it will be 0. Everyone understand why is it 10 millimeters? Understand? Y wave? 0.02. Everyone understand? Z wave? 0.20. Verify. Is it correct? Why is it correct? Anyone who do not understand where any of the value comes from? Tidak ni. Nah, yes. X wave tu. Sekejap, X ke Y? Okay. First, X axis y-axis, you know, right? This x, y, and z. So basically the coordinate of the centroid of this block, we want to know what is x, y, and z. Alright. So if you have a block like this, okay, the one that we have covered before, if you see the cross section, it will give you y and z, right? Macam kata bang? Meaning that if you draw from that perspective, dia ada macam ni. Betul? Saya bagi y and z tu. So from here you know that this one is what? Is 1/3 of 60, right? Okay, yang ni 1/3 of 30. So the coordinate you have to add this thing lah. So untuk y dapat 20, z dapat 10 campur 40 campur 20. Now for the x, actually if you have anything that we split just like this, the centroid will be always at the middle, kat tengah ketebalan. So because this is 20, then it should be at 10 lah. Sama dengan ni, sama dengan ni juga. Faham tak? Right? Make sure you understand, because question like this is just 3 marks. You just put in and then calculate, right? Dia taklah free flow, you kena dapat kerja juga. Maksudnya senangnya macam free lah. Okay, for block B, block 2, x wave. Zero 1, 10 mm. Y wave. Huh? Z wave. Right, 20 plus 20. For block number 3, x wave. Y wave 0, Z wave 0.01. Right, and the rest is just summation of A here, summation of x wave, okay, kat A, summation of M here, summation of x wave M, summation of y wave M, summation of z wave M. Then you plug into the equation. Now for, I think from the midterm you should know already that even the equation have its own mark. So do not skip that, meaning even though you can just calculate, but just taking the equation have its own mark, because that's the static part. This one is just mathematics. Any question before we go to the final question of the day? Soalan? Tak ada. Senang tak? Betul kan? Bukan senang tak? Buat paper isi, senang. Right, because there's no, I think question like this, there's no trick to it. Because like chapter 4 yang ada macam-macam positive vector, dia boleh tukar-tukar gambar, that will be more challenging. Normally, question like this is the question that you should always get to mark. Okay, right, this one. The composite plate in figure 5 is made from brass and so we have two materials. Brass row brass is 8.74 megagram per meter cube. Steel B 7.85 megagram per meter cube. Okay, and you need to determine. Okay, you need to determine two things. One is the mass. And then one is center of mass. So center of mass is this x bar Okay, so we'll take a look at the diagram and please try. How will you divide your block? How do you divide the? How many segments do you have? 3. Anyone have different number of segments? Divide like that, is it? So how do you level it? On the 3. Okay, that's up to you. Some might want to use A, A1, A2, B. But whatever, as long as you tally with your own table. Alright, so in that case, for this one is press, right? So this one is 8.74 milligram per meter cube times 0.225, 0.150, 0.03. Right? 25, 1, this one is still the same density, and then half times 0.225 times 0.150 times 0.03. This one is 7.85 and you calculate that, you get summation of mass, and that already gives you the answer of what is the total mass. Right. Okay, what is X way for segment 1? X. Formula number 1. X way. 0.075. Correct? Y wave? Why is it negative? It's on the left side, eh? Everyone get that correct? Or ada terlupa negative? Z wave? Alright, so segment number 2. X wave is? Dia tak tahu apa. Okay. Y wave? The same as this one, right? Z wave? Huh? Zero point? How do you get this one? It's 2/3 of 225, right? Very good. 1/5. Betul? Betul kan? Block number 3, segment number 3. X wave is? Y wave? Z wave? Then the rest is calculation. Anything that you cannot see? How do you guys set value? For those who need to, because for myself, normally if I'm doing the exam, I always show where it is. It's for myself, basically, just to avoid. Because sometimes, because this one is here, this one is at this different location, etc. Right? Sometimes if I do not draw, I tend to forget. But that's optional, as long as you get it correct. Okay, so we have covered all the past exam that I have. That is section 9.2. Any question? Anything not clear? So it is very straightforward. You know the equation. You know how to do the table. And that's it. Okay, just an understanding question here. Is the geometric centroid of the plate same as center of mass? Why? Is it the centroid the same as the center of mass? Yeah, should be no. Why? Because different material or different density, right? Is it different? Okay, if it is different, determine the location of centroid. So if you say, it's different, then determine the location of centroid. Okay, what do you do? G is center of gravity. You'll redo this again? Why not? Makanan Taiwan. Okay, that is actually a hint. When the mark is small like that, it means it doesn't require long calculation. How to calculate center of centroid without long calculation? Huh? Senang ni kan? Pergi tak buat makan. Yeah, because centroid doesn't require, meaning you avoid anything about density, right? So it's just the whole block. What is the centroid then? X wave, X is, S bar is 1.5. Y bar is 50 millimeter, right? And then 1125, right? So it's just understanding question macam tu lah. Jangan kira panjang-panjang ni. The answer will be the same if you do that, but it will be a waste of time because the amount is only for faham ke? Ada yang tak faham ke? Right. So, baru fikir soalan saya tanya. This has never been done before lah. Kalau for example the diagram gives something like this and you are asked to calculate the centroid, right? You don't need to have a long calculation. Anyway, so that's it. Next week we already will go into chapter 10. So make sure you keep track with whatever we cover. Do not delay. If you have any question, do not delay because next week is already chapter 10. After that we'll go chapter 6. After that we'll go to chapter 8. So it's quite fast pace after this. Okay. We have finished chapter 9. We haven't started our quiz for chapter 9 yet. Now, so my question is, do you want quiz for every component or not? Yes. Saya tak larat nak tanda. Kalau tuan ni buat objektif lah. Yang mana sekarang ejaan sebenar nama saya? Apa dah? Because many of you write many version of my name in the okay. Then in that case, then next week we will have two quiz. In the two class we have two quiz. One is 9.1 integration, and then the second is this thing, right? Alright, with that we end the session. Allah subhanahu wa ta'ala. Assalamualaikum.